Hello everybody, my name is Pawan Mehta and today we are going to learn about heat conduction between two parallel plates in Ansys Fluent 14 software. So basically we start now. So this is your analysis system. This where exactly you'll be getting your error messages and this is your properties bar. Right click. Okay, this takes couple of files and a new analysis system. Fluid flow, fluent. So this white box is actually your workspace. You see this geometry, mesh, setup, solution, results. Each of them is each module, a component. So geometry is one individual component, mesh is one individual component, setup, solution, and results is part of Fluent. So if you want to practice on individual components, you can. For the mesh, you just need the geometry. Geometry, you have to make it, and if you want to just practice the fluent, so you need a particular mesh to start with. So for this, you can go to right click, new component system. You can have fluent if you want, icepack, whatever it is, mesh, geometry. You can have these various components individually. So in this workbench, so this workbench, this workbench links all these components. So data from the geometry is transferred to the mesh. Data from the mesh goes to the fluent. So you don't have to do it manually. So now we'll select the geometry. In this we'll change it to analysis to 2D. Double click over the geometry. Okay, starting design modeler. You can see here. This time the working directory would be meters. Select the XY plane, normal. This option is for normalization. Sketch, rectangle, rectangle is done. Okay, press escape button. Dimensions, length and distances from 1 to here. You have a particular length and have a particular height. So this flow problem is about pre-convection between horizontal plates. So I'm thankful to one of my friend. He has given me the dimensions and the other data he has provided me for solving this problem, which is here the 3P, the conductive and kinematic viscosity, everything he has provided me. I'm thankful to him. So this line, according to him, is 1 meter. This is 0.05 meters. So it's basically very difficult to look at. Okay, we have the geometry in here. It's still difficult to look. You can zoom it, still zoom it. Okay. Now go to concept for making the sketch. Surfaces from the sketches. Select the sketch. Apply. Generate. So now the sketch is done. Geometry part is done. Always save file, because if your computer gets hang, you will be losing all the data. So you always save the file. It is very important. So this is heat transfer problem. Okay, save. So the geometry is done. We'll proceed towards the mesh. The mesh is also pretty simple in this case. Mesh, generate mesh. Okay, now this is very coarse mesh. You need to refine this mesh, make it fine, smoothing, high, update. So with this mesh is fine. For our case, we create refinement layers, insert, refinement, and select the edges. Because the near edge we are very much interested how exactly the flow will be happening. So we have selected the edges, apply, we will be putting 3 refinement edges, update. So this is how exactly the mesh looks like after refinement. Now select this edge and this edge. Name selection, zero flux. Wow. This is relatively at low temperature. Create name selection. Oh, wow. 5, save project. Before we begin, let me introduce with the flow physics of this problem. This is the hot wall, this is the cold wall. These are adiabatic wall with zero heat flux, zero mass flux. So what will be what will be happening due to buoyancy effect will be seen in this case. The flow, the fluid layer near to the hot wall will get heated up and due to and it will become less dense, so it will rise up due to buoyancy effect and it will touch the cold wall. Again it will get colder and it will become a bit dense and it will come down. So there will be circulations observed in this diagram. So this is the flow physics. You can study this if you want further explanation. You can study free convection between horizontal walls or horizontal plates. So now the mesh is done. You proceed for the setup. Update the project if you have such symbol in your project. The setup and level position. Okay. we'll switch on the gravity in this case. We to accompany buoyancy effect, we have to switch on the gravity. So this gravity will be minus 9.81 meter per second square. Now auto models, it will be laminar energy equation. You have to switch on energy equation because it's a typical heat transfer problem. Materials, it is air. Create, this density formulation would be Boussinier, and as my friend provided the values, I'll be providing all the values. So this density value is 1.5 or 1.127. C2 is 1.005. So that is joule. This unit is joule. Okay, that is kilojoule. So it is 1.005. And thermal conductivity, we have 0.0271. So the viscosity is 1.6. Kinematic viscosity is coefficient of thermal expansion, that is alpha 3.2 E minus 3. So look at these units and determine where is it. This is kinematic or dynamic viscosity. This is we'll do this unit calculation. This is mu into rho meter per second. This is dynamic viscosity, that is 1.9 and 19 point. This is dynamic 19.125 E minus 6. This is basically dynamic viscosity. Okay, so we have all these values. Change, create. Okay, yes. The material is done. Self-zone condition we don't need. We need boundary condition. This will be wall. Okay, it is wall. So edit, thermal, go to heat flux 0, correct. Okay, hot wall, edit, thermal, temperature 340. Okay, cold wall, edit, thermal, temperature 300 Kelvin. Okay, so this was the wall boundary condition. The reference value it will be from hot wall. Solution methods, it will be same. Solution initialization, standard initialization. From hot wall will be calculating it. Initialize. And calculation, number of iterations, let me be 500. Calculate. As you can see here, solution number 611 is converged. So the calculation is complete. Okay, graphic and animation, contours, setup, velocity, vortex, opacity, magnitude, display. So in this case you can see the velocity is a bit higher at this point. The velocity is the flow is circulating at this stage. The flow goes due to the hot fluid. A hot fluid rises, cold fluid falls. This is the principle. So it rises and this falls. So if you want, you can see the vectors set up. You can see the circulations clearly. So this was about free convection between horizontal plates. For more reference, you can study this free convection in the flow physics. The simulation is pretty simple. It is just that hot fluid rises, cold fluid falls due to buoyancy effect, which you can see clearly in this vectors. So thank you for watching the video. My name is Pavan Mathur. For any queries, you can contact me. Thank you.